The key for the worksheet is online as always, but I thought it might be helpful for some of you if I showed you where my work comes from. What we've just found out in the lab is that we can treat velocity just like you do distance in Pythagorean's theorem. So we essentially make a right triangle, and this is my Vx and my Vy, and I won't put a D anymore. Anytime you have a plane V, that means the straight line velocity. So that the Vx, now this can be either Vx 0, 0, 0, or they could all be finals, okay? But it just depends on what the problem, so you just kind of have to read the problem. But all the rules that you learned way back in middle school about a squared plus b squared equals c squared, and what you learned in trig, that the sine of the angle equals the opposite over the hypotenuse, that still holds. And at the top of your sheet, we've reminded you the sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent, and a squared plus b squared equals c squared. And that's really all we need. So in this problem, we've got Amber shoots an arrow her initial horizontal, so that's Vx. V initial x is 20. Initial vertical is 30. So I just use a squared plus b squared equals c squared. So that means you can plug the numbers in right away and solve, or in this case, I found the formula. I solved for V naught. I did not show all my steps here, so what I've really done is I've said V naught x squared plus V naught y squared equals V naught squared, and I'm solving for V naught, so I just took the square root. So that's how I got from here to here. I just substituted V naught for C, and this is my A and my B. And then I just plug the numbers in. The tangent is the opposite over adjacent, and I drew a little triangle here, so my opposite is my V naught y, and my adjacent is V naught x. And if you remember from trig, if I'm looking for the angle, if I know the tangent of the angle equals something, I take the inverse tangent. Again, make sure you're in degrees when you work this problem. So right off the bat, set your calendar to degrees. And we get our 56.3 degrees.